Okay, worksheet number 2. We're going to work a few. Let's do 12 and 13 and 16. Those are a little bit different. I feel like the others are fairly straightforward. So I think these might be the ones you have questions on. Number 12. The function has a first derivative given by f prime equals x minus 3 squared, x plus 1. At what value of x does f have a relative maximum? Well, I guess what makes this one different right away is that they're giving you the first derivative. So you don't have to find a derivative. They've done that for you. So pay attention to what they've given you. And in some ways, this is an easier problem because here's the answer. Now, what do you do with that? A relative maximum. Let's see. That's where f prime changes. Again, I don't have this memorized. I just think about it every time. A maximum looks like that. So f prime changes from positive to negative. That would make a maximum. Okay, well, we've already got f prime. So let's find the zeros. So we'll set that equal to 0. And then we'll do the number line thing. And then see where it changes from positive to negative. So again, in some ways it's easier because they gave you the first derivative. We didn't have to find that. They gave it to us. So the zeros would be 0 and 3 and negative 1. So negative 1 and 0 and 3. And I'll test some values into f prime. So maybe negative 2, negative 1/2, 1 and 4. And again, I don't need the actual value, I just need whether it's positive or negative. So if I plug in negative 2, I would get negative. This one's always going to be positive because of the squared. So negative times positive times negative, negative, negative. This one would be positive. I plug in negative 1/2. Negative, again, this one's always positive because of the squared. So negative times positive is negative. I plug in 1, I get positive, positive, positive. I plug in 4, I get positive, positive, positive. And maybe we notice, here's another reason to do this one, that there was not a sign change across 3. The reason there wasn't is because this was a double root. So sometimes you're paying attention, you might catch that. Other times you just kind of plow on through, plug things in, and realize there's not a sign change there. Okay, back up. What were we looking for? A relative max happens when f prime changes positive to negative. So if we were thinking about the graph of f, so that would happen at negative 1. There's a minimum at 0, and then nothing's happening at 3. So what we're looking for is x equals negative 1. There's a relative max because f prime changes from positive to negative. But again, the weird thing about that one, or the different thing about that one, is they gave you f prime. You did not have to take a derivative. They gave it to you. 13 is similar. The function f is defined on the closed interval 0 to 8. The graph of its derivative is shown on the right. This is the graph of f prime. So again, they're giving you the derivative. You don't have to take a derivative. They're telling you this is the derivative. Use this. Relative maximum, that occurs when f prime changes from positive to negative. That lets me know what I'm looking for. This is the graph of f prime. This is not f. So this is tricky. It's not hard, but you got to be careful and know what you're looking at. This is the graph of f prime. So I'm looking for where this graph, f prime, that's my graph. I want to know where my graph changes from positive to negative. Not there, almost does. That only happens right there at 6. So when x equals 6, the graph of f went from increasing to decreasing. So there's a max at x equals 6. This is tricky for lots of students, at least initially, to look at this and say there's a maximum there. Like your brain just doesn't think that way. You want to say the maximums are at 1 and 3 and 5, but those are the maximums of f prime, because this is the graph of f prime. So I don't care about those maxes. I care about what's happening on f. If f prime changes positive to negative, that means f has a maximum at x equals 6. Again, 1, 3, and 5, that's where f prime has a max. That wasn't the question. So be careful on what you're given and what they're asking. 14 is pretty similar. They're giving you the graph of f prime. They're not trying to trick you, right? They say this is the graph of f prime. It's the derivative of f, and it's labeled f prime. So they don't want you to get mixed up on what you're looking at. Let's get down to 16. Let g be the function defined by this. How many relative extrema does g have? So that means how many times does g prime change signs? And because of the way this one's worded, we don't care which way they change. We're not concerned about maxes or mins. We're just concerned with sign changes because we want to catch them all. Okay, so the derivative is 4x cubed plus 12x squared. We'll set that equal to 0 to start to set up the number line. I'm going to factor out of 4x squared. Make my life a little easier here. So x plus 3 is what's left. So x equals 0 and x equals negative 3. Those are the critical points. And it's tempting to say the answer is 2 because there are 2 critical points, but I haven't yet figured out if those are maxes or mins or neither. So on to the number line we go. Oops, negative 3 is to the left of 0. I'll check negative 4 and negative 1 and 1 into g prime. So I'll check it into that. I'll check it into the factored form. I think that's easier. If you want to check it into the original, that's fine too. If I plug in negative 4, square it, multiply by 4, it's really big, but I don't really care. It's positive, that's what matters. And then negative 4 plus 3 is negative, so it's negative right there. Plug in negative 1. In fact, this piece is always going to be positive. If I plug in negative 1, that's positive. Negative 1 plus 3 is positive. Positive on that interval. And if I plug in 1, it's definitely positive, positive, positive. Everything's positive. So if I'm looking for a sign change, it only happens once. It happens to be a minimum, but we didn't care about minimum. There's only one sign change. So there's only one extrema. Sort of related to number 12, that double root meant that there wasn't a sign change across 0. If you recognize the double root, you kind of know that ahead of time. If not, no big deal, just test them all and see what happens. The double roots, though, are also what throws it off. Like usually it alternates, and so some students like to use that pattern. But be careful, the pattern doesn't hold when there's a double root. So relative extrema, there's 2 critical points, but once we check them, we learn that only one of those is actually an extrema. Okay, hopefully that's helpful for seeing some examples from worksheet 2.